Yeah.
Okay. So the question here says the two functions that have at least one point of discontinuity. There are three types of discontinuities. One is a hole, two is a jump, and three is an asymptote, specifically a vertical one.
Okay, so
Any of those look, I mean, can you pick them out here?
7 and 8, right?
Yep, you got it. So I don't know, I guess we'll just say 7 and 8. And we will move on to the next one. Okay, so the next one is 17. So let me snip that in. I got too many windows open. There we go, new. The 6 functions that are bounded below. So bounded below means that they have like a min.
Mhm.
Okay, so like 2 has one here. Hopefully that's clear. You can see that is one.
Yeah.
Any other ones come to mind here?
6.
Let's see here. 6, you missed one though. What about 4?
Oh, yeah.
So
Okay,
2, 4, 6. Let me write those down. Now you've got this on your side so you can see it as well. 2, 4, 6. Okay.
And then 12 too, right?
12 for sure, but we missed 2 before that. So let's like we can cross them out too if we need to. Like no to 7. See how 8 goes down forever? That one does not. 9's the same problem. It goes down forever.
And then what about 10?
So 10 does. 10 does have a min.
Okay.
So yeah, it's kind of got a bottom there. I don't know how it is. Like that's that. And then same thing with this one here. So 10 and 11.
Okay. 10, 11, and 12.
Yep.
Got it.
I mean, you probably know this. These are in the back of the book, and there's no like work here. So I mean, just keep that in mind. I mean, we are doing it, but there's nothing to write down to show that you've done it. Okay. So 25.
Okay.
25. And I'll start recopying the graphs down here because I know it's kind of end behavior. Both of these. Grab these and copy them down. See if I can get that. Don't do that. Come on. Okay. So the 4 functions that do not have end behavior, limit as x goes to infinity, goes to positive infinity.
Okay.
So that means, so this, when it goes to infinity, what that means is that as it goes to the right, so like number 1, it goes to positive infinity. Number 2 also goes to positive infinity.
Yeah.
So so like maybe you see this here, 10 also goes to positive infinity.
Yeah. But then like 3 doesn't.
3 doesn't. Okay, so 3 would be one that does not. Okay, 4 does not. It just sits there and oscillates. 5 goes to minus infinity.
Yeah.
So that would also be 1. Which ones, what else are you seeing here?
Okay, so 6 goes to positive infinity.
Agreed.
7
7's a little weird. It just keeps
Is it?
going up though. So it actually does go to infinity.
Okay, and then 8 doesn't.
8 does not. Okay, agreed.
And
9 does.
Yep.
So that leaves 11 and 12.
Okay,
All right.
looks good.
Okay, question. What are we up to? I keep losing the
26.
26. Okay, I keep losing the chat. That's why I can't snip these in faster. 26. The three functions with end behavior. Okay, so this one we can actually do pretty quickly because we actually already answered it. This is saying when it goes the other direction. So when it goes, this right here means as you go left. This means you go down.
Okay.
So an example would be like number one.
Yeah.
So yeah, that as you go left and go down.
Mm-hmm.
Okay, so find the other two, please, and give it a shot.
Um, is it 7 and 9?
7 for sure, and 9 for sure, yeah.
Okay. And then 35 is the next one.
Okay. $35, okay. All right. Oh, so do we have to answer A through whatever on these? I guess we do.
Yeah. Yeah. So
Oh boy. Okay. So the graph of this, let me just draw it real quick here. It's over here at 10. This is at, I'm sorry, ooh, that's really wrong.
it's the other way.
Yeah, no, well, it's that way. It's 10,
Oh yeah, it's on the other side.
10, 0. Yeah. Okay. So it looks like that. Okay. So now let's do part A. It's increasing if it's going up and to the right, up and to the right. Okay. So that's happening everywhere, but everywhere that it exists, like over here on the left, it's not doing that. So it would be from 10 to infinity. And these are always X values that it's increasing or decrease. So thankfully it's not decreasing anywhere because it decreasing means it's going down and to the right.
Mm-hmm.
Okay. So that's sometimes they say empty set or like this means nowhere. I don't know if your instructor's using any notation like that, but
Okay.
that's that. Part B is saying odd, even, or neither. So all right. How much do you think this will be covered? Because I mean, we can go into a lot of understanding of part B if we need to. Like, is this just a one-off? Like, you're not going to see it again, or?
I don't think we're gonna talk about that again. I mean, that's never been brought up before, so I'm
Okay,
not
so
overly
we'll
concerned.
just go with neither and move on
Okay.
to something else that we can talk more about. Extrema.
Mm-hmm.
So this means a min or a max, and you're also kind of looking for endpoints. So if we go back to the graph, this right here is an extrema.
Mm-hmm.
It's the absolute min.
So I just put like 10, 0 absolute min.
Yes,
All
and
right.
those words should make sense. We're not going into like all the possibilities. We just can't. But C like B as its own kind of like segment.
Mm-hmm.
D is probably the most relevant one for you as a student in this class. D is asking like first, well, what is the parent function? The parent function is the square root of X. So then what is happening when you have the square root of X minus 10? It means 10 right.
Yeah. Got it.
Okay. All right, what's the next one here?
36.
Another one of these.
Yeah, and we gotta do 38 too.
38, okay. All right, 36. Okay, so the graph of this sine x plus 5, I mean, you can get a calculator if you need, or Desmos or something, but you go up 5 and it just sits there and it oscillates forever. Oscillates forever. So
Okay.
A is where it's increasing or decreasing.
Mhm.
This one's kind of tough because it's increasing like here and here, and then it's increasing from here to here, and
Yeah.
so on. And so it's increasing on an interval. Now it's increasing from minus pi over 2 to pi over 2. That's this point to this point.
Okay.
Plus, this is where it's a little weird. Plus, and then there's a like the how do you get to the next one? So the next one over here is at 3 pi over 2. So it's 2k pi. And really, you're probably supposed to add them to like each of these. So it's minus pi over 2 plus 2k pi. So that gives you that point, and then this next one,
Mhm.
and then this next one, and so on, or backwards, comma, pi over 2 plus 2k pi. Maybe you saw that in class. I don't.
Yeah, I think so.
Decreasing. Decreasing is going. So these are increasing. These are increasing. So the
Mhm.
other ones are decreasing. So it's decreasing on the other windows. So that would be pi over 2 to 3 pi over 2. But again, like you have to account for this 2k pi.
Yeah.
So that's pi over 2 plus 2k pi, comma 3 pi over 2 plus 2k pi.
Got it.
All right. B, this one is even, and that's because it's the same. No, it's not even. This one is neither. We shouldn't talk about that.
Okay.
C is the extrema. So if we go back and look at the picture, like each of these points down here is a min, and each of these
Mhm.
points up here is a max.
Yeah.
So we could say it has a max at pi over 2 plus 2k pi. And what that does is that gives you this top one, then the next one, then the next one, or the previous one, and so on. And then similarly, it has a min at 3 pi over 2 plus 2k pi. And see, this is all coming from the unit circle, by the way. This is all related. Like here, it's a pi over 2 sine is equal to 1, and down here at 3 pi over 2, sine is equal to -1.
Yeah, I remember that.
Okay, that's where this is coming from. I mean, these are actually really good questions to give sort of as did you actually learn and remember everything you need to learn in some of your previous classes, because there's like everyone's very in depth.
Mhm.
Okay. D, the parent function here is sine x, and
Yeah.
then the sine x plus 5 means you're going up 5.
Got it.
And when it says 12 basic functions, that's just that's a parent function thing.
Yeah. Okay.
Okay,
And then
38.
yeah, that's the last one.
Okay. Oh, that's not going to work. All right. Okay, so the graph of this one, this is the line y equals 2, and it looks something like this.
Mhm.
And it goes up forever. So the first one is where, I'm sorry, A is where is it increasing? And again, where is it going up and to the right? And it's going up and to the right everywhere. Minus infinity to infinity.
Okay.
If it's increasing everywhere, Well, it can't be decreasing anywhere. That's where
Mhm.
it's going down and to the right. So that's nowhere, NP set, or you just say, D and E, something like that. Part B is the even, odd, neither. This is one of those neither ones again. C is extrema.
Mhm.
So this one does not have any.
Okay.
And the reason is because it approaches this value, but it never actually gets there. And then
Yeah.
on the right, it just goes up forever.
Mhm.
So this, like the previous ones would ask for bounding. Like if something is bounded on the bottom, that means there's actually like a smallest value. And if it's bounded on the top, there's actually a maximum value. And this doesn't have either of those.
Got it.
Part D, the parent function is y equals e to the x. So your problem, y equals e to the x plus 2, just means you're going up 2.
Okay.
All right. Do you want to do section 2.1 first or 2.2?
Let's do 2.1.
Okay. All right. So I got this pulled up here. It says, determine which are polynomial functions. For those which are, state the degree, leading coefficient. Okay, so on, so on. All right. So we're going to grab question number 2 again here. All right. All right. So we're on to 2.1 and a bunch of questions here. And let's see all the things that it asks for. Okay. All right. So is this a polynomial? And the answer is yes. So until we see an exception, I guess there's nothing to say here, but you're looking for division by x, or x to a negative power, or roots, or stuff like that.
Yeah.
Okay. So the degree is the largest exponent of x.
So 1.
So 1, and then leading coefficient, you identify whichever term had the x in it, and it takes the sign with it, so it would be positive 2 or just 2 with it.
Okay, so it's just like the
Yeah,
yeah.
this is very straightforward here. This next one, I actually don't know. I want to say this is a polynomial.
Because
The
is it like x to the 0?
Yeah, it's degree 0. But then there's no leading coefficient.
Yeah.
So I'm not sure. You may want to ask your instructor
Okay.
on this one. You might say, I don't know, this seems weird. To me, it does not exist, but it could be 13, but I think it is. It just guessing it is. So
Okay.
hopefully the next ones are a little bit, nope, we go right to 10. So, okay, let me just do just really quickly. I'm not going to spend much time. I want you to see which ones are not and why. So
Mhm.
this is not because of the negative exponent.
Yeah.
Okay. This one is not because of the cube root.
Mhm.
Okay. But occasionally instructors will do things that'll be a little bit weird. Like they'll go, it's 2 over x to the negative 2, but this is really 2x squared.
Yeah.
So this seems like it's wrong, but when you simplify it, it's not.
Yeah. Okay.
Okay, so let's go to number 12. I'm sorry, 10.
Mhm.
And the instructions say to write the equation of the line. Okay. Equation of a line. So this is x and this is y. This is x and this is y. And if I give you 2 x's and 2 y's, you can determine the slope.
Yeah.
Now I'm going to arbitrarily choose the first set to be 1, the next pair to be 2. So you got 7 minus 2 over 5 minus 1, which is 5 over 4. There are how many equations of a line? Do you remember?
3.
3. The best one to use when you don't have to do anything is point slope form,
Mhm.
because you just have to put the stuff in. So this is the slope.
Yeah.
And then you just pick an x and a y. So I'll pick the first one. Y minus 2 equals 5 over 4, x minus 1. And there you're done. You're done. You don't have to do anything else.
Okay. Got it.
Okay. This is going pretty well. So let me have you do 12 on your own, please. There's nothing unusual about it. It's the exact same question as this one, just different numbers. So just give that a
Okay.
try, please.
Okay, so I got y minus 2 equals 1/2 in parentheses x plus 4.
That's right. This is what I wrote. Is that what you got?
Yeah.
Okay. So you used, which point did you use?
Oh, wait. One sec. I missed it. I used one from each point.
Yeah. So I was gonna say, it's not like picking out clothes where you grab some of your sister and your mom. You gotta use your own wardrobe here. So either that one or that one. And really all you got to do is change, one of these numbers. So,
All
either
right,
one's fine.
it's just y equals 1/2 parentheses x plus 4.
All right. So that first one, it works. And the second one, it also works. Okay, good. So next one here is 14. Exercises, match a graph to the given function, explain your choice. Okay. You have to do a couple in this set here. You have to do 14, 16, and 18. So what I'm going to do is just snip in the graphs and then we'll just match them all up.
Wait, I think our next one is 28, not 14. Because we're on
Oh.
2.1.
You are right. Thank you for, good on that. 28. There it is. There is 28. 28. Lots of instructions here. Okay. Yeah, always tell me if we're going to do something we don't need to, because then it just takes too much time here in the end.
Yeah.
All right. Write the equation vertex. Okay. Okay, so the instructions say here, they say find the vertex. Okay. And when it's in this form, ax squared plus bx plus c, the vertex is x equals minus b over 2a. That's the x coordinate.
Mhm.
So your b here, this doesn't work out very nicely, but your b is 7 over 2 times -2. So that's -7 over -4, which is 7 over 4.
Mhm.
The c value you get from putting this right here back in for x. I assume you're allowed to use a calculator on this one.
Yeah.
Yeah, so you want to grab a calculator if you've got one handy.
Okay.
I'm going to do the same, and then we'll try to come together here and get the right answer. Don't forget to use that math enter to get the decimal into a fraction. So that I get 25/8 when I do that. Up to you if you want to
Yeah, okay.
check that, but that's 7/4, 25/8. So this equation right here, it's related to this one, x minus h squared plus k. The thing that's true is a is always equal to a. So you're actually kind of done here. Your a is 2, your h is this minus 7/4, and your
Mhm.
k is 25/8. I think.
Okay, yeah, I got it.
This might actually be like 4x minus 7, but okay. Yeah, so that's that. What else does it want you to do here? Yeah, that's it. Oh,
Yeah.
the axis of the graph. The axis is x equals h, so that's x equals 7/4. This is h and this is k.
Okay.
30.
Yeah, 30.
30. This one we'll rewrite before we start. You always want to put it in what's called descending order.
Mhm.
So that's 4x squared. The sign always goes with it, so minus 2x plus 6. And we'll do the same thing again. The x coordinate is minus b over 2a. So that's minus a minus 2 over 2 times 4. So that's 2/8, 1/4. To get the y value, you have to put that back in to the original or our modified one. Either one is good. If you got a calculator, go ahead and give that a try if you want.
Okay.
You can also graph this as well. Like if you had a Desmos available to you at home, or if you're doing a take-home exam, you can always do it that way. So y is 23/4.
Yeah.
Okay, so then it's your y is equal to 4 x minus 1/4 squared plus 23/4. Because this is your h and this is your k, your
Got it.
vertex. And so the axis of symmetry is x equals 1/4. It's always x equals h
Mhm.
on that.
Okay. 45 is our next.
45. Okay. Describe the strength and direction of this. Okay. So you're starting to see more of these questions on the SAT, ACT exam. They're asking more qualitative questions, like interpret questions.
Mhm.
So there's strength generally has 3 possibilities: weak, moderate, and strong.
Okay.
And then direction, there's 2 options, generally negative, positive, and then maybe like no direction.
Yeah.
So positive is going up and to the right, negative is going down and to the right. So you
Mhm.
generally start with that one. So this one is positive, this one is negative.
Yeah.
And then strong is if the numbers are kind of close together. So this one would be considered strong because they're kind of like all near a line.
Yeah.
This one would be considered moderate. Okay. Because
Mhm.
they're kind of close together, but they're not as well as the last one. So you might be wondering, well, what would like no, or let me just choose, like, let me go positive here. Positive week would be like that. That would be like week, positive week, because they're kind of all going up to the right, but they're just all over the place.
Yeah.
To get an idea of that.
Mhm. So is that all we have to say for those questions?
Yes.
Okay.
50.
Yes.
Not seeing the page. So what I have goes from 169 to 171. We can do 58, but not 50 or 52.
Oh, oops.
Or you can, I mean, if you got time, you can send that, but
Let's just do 58 right now and then see if we have time.
got it. Okay. The Welcome Home Apartment Rental Company has 1,600 units available, of which 800 are currently rented at $300 per month. A market survey indicates that each $5 decrease in monthly rent would result in 20 new leases. Okay, so revenue is price times quantity. So the current revenue is $300 and the quantity is 800.
Okay.
You see that? Like they're charging that, which I mean, this is so out of date. I mean, nobody, that's not even close. You couldn't even, you couldn't even get that price in I don't know, the worst city in America, I think.
Yeah.
Okay. But they're saying, and this is what's important. And actually this question comes up in business calculus, business classes. Like this is like the classic, question. It's like, and what ends up happening is like they decrease the rent, but then more people want to buy.
Mm-hmm.
And intuitively that makes sense. Like if something is less expensive, people want more of it.
Yes.
Okay. So for every $5 the rent goes down, the quantities go up by the same.
Okay.
So this is the amount it goes down, and this is the amount that it goes up. So what you have to remember, because you might get a question just like this on your exam or quiz or whatever, is one of them's a negative, one of them's a positive.
Yeah.
And it's not always this way. Like it could be that they increase the price, so the number of like tickets goes down
Mm-hmm.
that it's sold. Okay. So this is your revenue function. This is your part A. This is part A. Now notice I'm not multiplying, I'm not doing anything like that. It doesn't tell me to do that, so I don't need to. All right, so part B, we're going to go to the calculator or Desmos. Do you have an opinion? Do you care?
Let's just do Desmos.
Okay, let me get that up, and I'll just snip in the graph when I'm all done here. Okay, so when you're using Desmos, you do not have to multiply out. You can do 300 minus 5x times 800 plus 20x. They're trying to help you out here by telling you like the x values, like, oh, go from 0 to 25,
Mm-hmm.
0 to 25, 0 to, whoa. Huh. Oh, wow. It's just way up there. Okay. I'm trying to find this. I know you can't see my screen, but I'm like, where is it? Where is it?
No worries.
It's there it is. Okay. So there's your max. All right. I tell college students that, or I used to when we actually had to go into the classroom a lot, is I was like, this is the hardest part. Just graphing this will be the hardest part to get the window, and
Yeah.
it'll take you the longest amount of time in the exam, not the. So, okay, so this is part B. Now they only wanted it from 0 to 25. They're just trying to help you because they're saying like, just look in this window right here. You're like, okay, well, you can see that that's where it happens. That's the X value.
Uh-huh.
But that's not what they're asking for here. X is 10, But the price you get from putting it back into this right here. This whole thing is the price.
Oh, okay.
So the price here in part C is 300 minus 5x, or 300 minus 5 times 10.
So it's 250.
Yes. Believe it or not, this applies to maybe, I mean, maybe to a lemonade stand as a kid, or, anything you might ever sell. It's like, if you raise the price, you're going to sell less of them, but you might find that you sell, you don't lose that many, so that the price increase, you can achieve more profit or revenue in the end.
Yeah, the supply and demand.
Yes, it's related to that, and it's actually very, very useful in real business. Okay, so that takes care of that lesson.
2.1.
Yep, 2.2, page 182, question 6.
Yes.
Power function given that CG, K, and pi represent constants for those that are power functions. The power constant variation. Okay. Is this a calculus book that you're using?
Pre-calc.
Okay. Wow. This must be an older book.
Yeah, I think so.
Okay. This thing, it wants to know whether something is a power function or not.
What is a power function?
Yeah. So a power function. How do I want to do this? Yeah. Okay. So the power functions have this form. Do you have the answers to the odds available?
Let me check my book.
If you do, can you tell me whether they classify 3 as a power function and 1 as not?
Okay. Three, not a power function. And then what other one did you want?
That's enough for us. Okay, so they're calling a power function x to the n. Okay, which is true. So the power function is, this is a power function because it's a variable to a these are so weird. Okay, I'm sorry. A CG, K, and pi. Yeah. Okay, so this stuff right here is the constant of variation. This 1/2 K is the constant of variation. And then the power is 5.
Oh, okay.
For 8, I believe you have to do 8. I'm going to write it here because it's very similar. Okay. The constant of variation is what I'm circling. It's the constants in front of the variable. And then the power is the exponent. The power is the exponent.
Okay.
And we got to do 10. CGK and pi represent constants. Okay, so in 10, this one's a little bit odd because, okay, well, It doesn't say that M is a okay, well, we'll just go. So this is a function of A only. So A is the variable.
Okay.
Okay, the power here is 1. So the constant of variation is just this thing here. This M is the constant. And 1 is the power because it's the exponent.
Oh, okay.
So in 11 through 16, and it looks like we got to do 14 and 16. They want to know if it's a monomial function. And if
Mhm.
it is, state the degree and the leading coefficient.
Okay. We got to
Okay.
do 12 though.
Oh, we do have to do 12. Okay.
Yeah.
Okay, so this is a problem here. This -5 is a problem.
Yeah, because it's not
It's not a polynomial.
polynomial.
So for
Yeah.
something to be a monomial, it has to be a polynomial.
Uh-huh.
So this is just a big no. And
Okay.
then we don't do the rest. 14 is equally a problem, but for a different reason. This right here is an exponential.
Yeah.
So this is also a no.
Mhm.
The last one, 16, it says A equals L times W. And in the instructions, it tells you that L is a constant.
Mhm.
So another way to write this, and this is where it's really clear, is if they wrote it A parentheses W equals L times W, this tells you that it's a variable in W.
Oh, yeah. Okay.
So now you can answer the question. Yes, it is. It's a monomial. Monomial means it has one term. Well, they all have one term. So it's just, whether it's a monomial or not. And then the leading coefficient, L, is the leading coefficient.
Got it. Okay, and then 18 is the next one.
18. Write the statement as a power function equation. Okay. We may actually get through all of these.
Yeah. 3 more.
Okay. The volume of a circular cylinder with fixed height is proportional to the square of its radius r. So you don't need to know any formulas, but you have to read this and interpret this. So the volume of a fixed cylinder is, so the is tells you where the equal sign is, V equals the square of its radius. So that's that. That's what it means by the square of its radius down there. The
Mhm.
proportional part means that you need a constant of variation, which in this case it's K.
Oh, okay.
You did these previously. You did these in another class where you would get numbers and then you would like solve for the value of K.
Uh-huh.
Here you're just writing these out.
So that's all we have to do?
Yeah. There's
Okay.
actually like a more interesting, important thing here, but they're not doing that. They're just giving you stuff here. So volume of a gas varies directly. So that's V equals. There's your variable V directly, indirectly V equals the absolute temperature T. So there's T. And we've got a K in front.
Okay.
And then 57. These
Mhm.
are so all over the place. Okay. All right, this one. Okay, so draw a scatter plot of the data. Find the power regression model.